Okay, welcome. I am Russ with Sapphire Energy, and we are here at a cabin, remote off-grid, and they are using a solar system to power up a bunch of lead-acid batteries. But the problem they're having is that they can never tell if their batteries are full or not because they don't have any kind of battery monitoring system. So they have a combination of solar panels and a generator and several loads, and they leave a fridge running 24 hours based off of the DC. So when they do show up, they're never sure if the batteries are actually full or not, and if they need to run the generator or not. So they find themselves running the generator in the darker months when they don't actually need to, as well as not running them sometimes when it's brighter out, but they should have because they don't know what their batteries are at. So we're going to install a Bluetooth battery monitoring system today to let them keep track of that and give them a nice, easy to read display plus an app on their phone to check in. Okay, let's get started. Okay, so we're going to dive right into installing the Bluetooth monitor here. This is the BM02 model and the 100 amp variation, which is good up to 150 amps of peak energy. It comes with a couple of instruction booklets for you for that monitor and the app itself, but the installation is pretty straightforward. I'm going to pull your monitor display unit out. It does come with a back strap if you want to cut it into a panel, but today what we're going to do is install without the back strap, and we're going to use one of the surface mounting kits here to make a nice clean installation. The actual shunt unit here is what we're going to install in the negative battery cabling between all of the loads and the battery. There should only be one cable between your battery bank and the rest of your system on the negative side, and it should go through here. It's going to connect to your B minus, your battery minus, and then your P minus is going to go off to your loads. It comes mounted on a little plexiglass unit here, so it makes it super easy to mount, and comes with a 3-meter cable that clicks from here into the back of your monitor. Installation is quite straightforward, and we're going to show you how to do it today. Installation tools required. You will need one fairly small blade screwdriver to get into the terminals on this guy here for the positive connection to power the meter up. Other than that, you just need some basics like wire strippers. For the 100 amp unit, it's a 15 millimeter socket for the bolts on the shunt, and then standard like Robertson and Phillips screwdrivers. You can either use a jumper cable to extend from the shunt to your battery bank, or you can cut the cable and crimp a new end on, whichever makes you happier. In my case, the way I want to mount this guy here is to a to a plywood backing. So what I'm going to do is actually just drill these little holes out a tiny bit to make the screws fit through a little easier. And of course you can do that as long as you're not mounting it to anything metal. It doesn't even matter if the screws are actually touching the sides here. So on top of that, we're going to use probably a drill and an impact driver, and I've just got a drill case with me as well with assorted sizes so I can deal with whatever comes up. In my case, I'm going to use an auger bit here to feed the actual data cable, or the signaling cable, through the wall. I'll spin around here and you can see what we're going to do. We're going to come out of our battery box down here. We're going to disconnect this cable here, which is our negative back to our battery, and we're going to mount the shunt right here. And then we're going to run the little signal cable up, over, pop out here, and we're just going to poke through the wall here. You can see that normally there's a cabinet mounted here, so we're just going to tuck the wire in behind, poke through the wall, and then inside the kitchen space we'll mount the nice little display so they can see the state of charge and if it's charging or discharging and all the rest of the battery parameters that they want to keep track of. As always though, before we get started, first most important step is to turn off all of your loads on your inverters and your system, and then turn off your battery connection. If you have solar set up, note that most of the time the controllers are happiest if you turn off the solar power first and then turn off the battery connections. That will disable power to the system without frying anything, and then we can go ahead and get started. Let's pop under the house and have a look here at what we're dealing with here. So down here we've got 4 6-volt, 430 amp hour batteries. These are an L16 type. So this is plenty of power for them usually, but since they don't have a cohesive system, they can't tell what's really going on. You can see it runs up through a and our fuse holder there. That's good on the positive side. And then we're going to have our two cables going up, our positive and our negative. The negative cable is the one we're going to interrupt with the shunt meter. And that's all we got to do is just either cut that cable and crimp two new ends on, or we can just pull the cable off the negative terminal up top in the cabinet and add a little jumper on. Either way, it's that, a couple of screws, and our monitor is basically installed. Okay, so just for those of you that are curious, a quick little run through on the system that the owners here have installed. There are two strings of solar, so there are two solar charge controllers installed. They feed down through fusing into a safety hub down here, which I highly recommend. It's an excellent product. And then they're also feeding their inverter to run their electrical load, like lights and charging phones and batteries, and charging their fishing batteries and laptops and things like that. And then down here, we've also got an Ames power charging unit, which I also highly recommend. Love these units. On a 12 volt system, they do up to 75 amps, and on a 24 volt system, they work for both. They do about 35 amps, and they work with lead or lithium iron phosphate or AGM and other batteries. These can actually be installed in an RV as well as your converter and give you just oodles of power to do things. They've actually gone a step further here, and we've got a little high voltage contactor here so that the unit actually disconnects, and it's been wired up so that it is only ever powered up when the generator is running, which is handy so that it's not just sitting there trying to idle, and that keeps it separate from the inverter loads. So if you'd like to see a diagram or any more information on how that was sort of done, let us know, and I can sort of give you a basic rundown on that. And then in this case, we've actually added a Anderson connection and a disconnect there, and they've got a set of jumper leads we cut in half and put an Anderson connector on, and so they can take this unit out, unplug it, run it off somewhere else if they need to charge up a tractor or a motor or truck or anything, their RV even that broke down or whatever. They can use it like a little portable charger. The Ames units are CSA and UL listed as well, which is nice, so you get the extra safety backing there that they've had the unit certified, and they are totally safe to install in things like your RV or in the cabin installation here. Okay, so power's off. So first step's going to be to disconnect the negative cable that we had there, and push that back down a little bit here. I may also circle back and add a crimped end onto this here, but these types of lugs are acceptable and handy if you're off grid and you're out in the middle of nowhere, because they're easy to rework. Just as always, I recommend checking, put a quick load on it once you've done some electrical work, and just come back after you've had a load for a while and just check and make sure that nothing's getting warm. I think we'll just push that back down there a little bit. I think we'll take this guy. And now, make sure we orient this the right way. P minus to the bars, B minus to the battery. I think what we'll do is try bolting make sure that's nice and tight. Got good surface contact there, lots of good current flow. And then I think oh, look at that, a couple of screws I I don't even need to actually drill them out. How lucky is that? Now, you'll have to forgive me. I did cheat and mark my holes a little ahead of schedule here to make sure the video went smoother. But hopefully you can forgive me. Now, this is a common misconception in electrical. You need this to be snug, but not crazy tight. You don't want to break it. That's all it takes. And again, once we're installed, I'll come back, I'll put a big load on this, and I'll check and make sure that nothing's getting too hot. Okay, that part's looking pretty good. Next, we'll move on to putting in the power cable from here. We'll need to run a positive cable up to our fuse box. And the signal cable will just click in here, and we'll use some straps and zip ties to clean it up and run it up nicely up the side of the cabinet. Okay, so included with our unit here is the positive cable. There's no load passing on this wire, so it's a nice thin gauge. You can put it direct to your batteries if you're installing your shunt right beside your batteries, but since we've got a box here and the batteries are down under the cabin, I'm gonna go up to our solar, or our fuse distribution box and hook it up there instead. I feel that just gives it a little bit better protection in case something shorts out, that this tiny wire isn't gonna burst into flames or anything. But now the tricky part for this is you need quite a small screwdriver to fit the little green terminals in here. Okay, I've installed many of these, and every single time I say put this wire on before you screw it to the wall, and every single time I forget. So through the magic of editing, I'm going to pull this off the wall, hook it back up again, and put it back on the wall, because that just makes life a little easier. If you're smart and you're watching the video before you start the install, put the wire on before you mount it and save yourself the headache that I can't seem to avoid no matter how many times I do this. Okay, we've run the positive cable that feeds our shunt up to my fuse box here. And again, this can go straight to your batteries if that's an easier connection. The ring terminal it comes with should fit a standard M8, M10 type stud, so you can bolt it straight to one of our lithium batteries. But in my case, it doesn't quite fit in my little connection here. So I'm just gonna crimp a slightly smaller ring terminal on. Now, remembering again that I've got all of the power off right now, so there's no energy on any of these terminals, so I'm not worried about shorting things out with my tools. I know lots of guys will try and do it live, but I just don't see the point in sparking your tools or damaging terminals and things like that. If you spark one of the terminals, you ruin it, and then it doesn't work properly or it gets hot down the road. So take the time to shut everything down, do it properly. And then in my case, I'm gonna need to put a fuse in. Now, again, this thing doesn't draw much. The standby current is somewhere around, I think, 40 or maybe 50 milliamps with the backlight on the display. This is really just a reference point for it to actually be able to measure the voltage so that it can calculate your watts and your loads and power the display. So I'm going to use a 2 amp. That's the smallest one I've got. 1 amp would be good as well. But you probably don't want to go too much bigger than that. Just in case something breaks or chafes later, you want to have your wires protected as possible. There we go. Put the lid back in. Perfect. Well, we can jump on the inside and start wiring on that. Okay, well, I made the faux pas and forgot to turn the camera on before I drilled the hole through the wall here, so we'll just pretend right now that I'm doing it. And then I've used a 1/2-inch drill bit to drill through the side here. You can fit the cable through a 1/2-inch drill bit, but if you need to tape or do anything else, it's a little easier with a 5/8, and going through walls, it's much easier to use a ship auger like this. So if you're working in a cabin like I am in this case, the ship auger gives you the length you need to go all the way through the wall. Just be really careful when you drill from the outside in that you don't push really hard. Otherwise it'll blow all the wood out on the backside and make a really ugly mess. But yeah, so that's it. Pretty easy. I've already done the wires up the inside of the cabinet here. I'm just going to poke them through the wall, like you can see here now. And then we're going to feed them through the wall into the cabin. And to do that, I'm just going to go inside, drill a little bit of a better angled hole because I missed my mark just a teensy bit. And then we'll feed a wire out and pull it through. And after that, it's just a matter of the 4 screws on the mount kit here. And then fish the cable through, plug the monitor in, turn everything back on. Okay. Okay, so on the inside in the kitchen here, you can see where my hole came through. I missed a little bit. So I'm just gonna use the drill to notch it over a little bit with the goal that the cable will come into the back of the mount here. So I can mount this like this here, and then the screen will snap into it. And I needed to do that in a bigger hole. And we're just going to use a stiff piece of wire to feed down. And if I'm lucky, find my other hole. There we go. That actually went outside, so you can just hang tight for a sec. Nice and gently. There we go. And just use the 4 screws included with it. A little Allen wrench to mount this guy. And with the screws attached, we just take our monitor and our cable and plug it in. Now I've turned the power back on already, so our monitor's coming to life. We'll just tuck that excess bit of cable into the wall and click her back onto the mount. We'll just run through the settings real quick here. Now you can do this from your phone as well using the apps. You just press and hold set to get into your programming mode, and then press set to accept this. This setting 1 is going to be for our battery bank. So I'm going to set this to 400 amp hours. There's banks about 430, but this will be close enough for them. And then we'll press the return key to drop out here, and we can press the up key to go up here. Now, what we can do here is set setting 2. Setting 2 is the voltage that when you reach during charging will trigger the meter to automatically reset to 100% state of charge showing. So what you want to do for this, ideally on like a lead acid bank, you would set this to somewhere near the equalizing voltage. So every week or two when you're doing your equalizing, it will automatically recalibrate to 100%. If you're using a lithium battery and there's no equalizing, I suggest setting this to somewhere around the 14.3 mark, or a 28.6 volts if you're on a 24 volt bank, because that will give you an automatic reset every single time that your charger's running and you're basically up to 100%. Oh, I'm pressing the down button, that's why. Bump my way through here again. So this is a 24 volt bank. So I'm gonna do that. I'm gonna press set again to move over. I'm gonna press the up button. And I'm gonna set it, for these guys, they're on a lead bank, so I'm gonna set it to 29 volts because that will trigger when it goes into its equalizing charging. And then that should be good here. And then we'll go up to setting 3, which is the 0%. So this meter will also recalibrate itself automatically when it reaches a known low voltage. So you can set this to something like on your lithiums, I would set it down around like 10.5, so that the unit will automatically drop to 0% if you end up that low. Hopefully you never end up that low, because around 10 volts is usually when your protections kick in. And then obviously double those numbers for a 24 volt bank. So we'll press set to come in here. And then on the 24 volt bank here, I think what we'll do is we'll set this to around 20 volts because we're never ever going to want to get below that. And again, this number is not used on your day-to-day. This is only if your battery bank starts dropping way off and your meter is out of sync a little bit, which can happen over time. When it gets to 20 volts, this meter will automatically set to 0 if it hasn't got there already. That way when you start charging back up again, it'll start charging and counting all of the amp hours that are going into the battery. So press the return key here, and then we'll go up to setting 4. Setting 4 is an alarm voltage. I'm not going to worry about an alarm voltage on this one. You can do that. And then set 5, I believe you can set how many amp hours are actually in the battery right now. So I'm going to skip out of that. I'm going to drop out of here. Now we are at 27 volts. So we're definitely not fully charged, but we are showing that we're putting about 26 amps into the battery still. It's clouding over, there's a bunch of rain coming, so the solar's not working quite as effectively right now, but that's fine. Just to show you how this works, because we just installed the meter, it thinks there's only 2% in there because it's only been on for a few minutes. You can at any time calibrate this back to full or 0 by holding the button. So I'm just going to hold the up button, and you'll see it automatically goes back to 100%. So at this point, I'll leave it that way. And actually, you know what? I'll demonstrate. You can go down as well. You can do the down button and hold, and it'll drop to 0. Okay, and you see the little light go red there because that's basically like an alarm. It's telling you that it's super low. But I'm going to leave it up at the 100% for now. That way, when the clouds roll in, we're up over 400 amps probably in the bank now. So this will work for everybody. Okay, so that's it. The install is pretty straightforward. Remember the wire trick with putting the little positive wire on before you mount the shunt part. That definitely saves you a bit of time. You don't have to take it off again. The meter's working awesome back here. It's counting all the coulombs and the amp hours coming in from the solar system right now. Like I said, the rain's starting to roll in, so I gotta go clean up everything outside so nothing gets wet. And yeah, if you have any questions, leave comments below, and hopefully I can pop in and answer them.